Hello, first grade teachers. The purpose of this video is to provide an overview of the standards, intended pacing, and sample instructional strategies for Unit 3A, sorting, sifting, shifting, shapes, and patterns. In this portion of the video, we are going to review the AKS and Indicators of Achievement, or IOAs, for Unit 3A. The AKS is the overarching knowledge and skills that students are expected to master. The IOAs are the learning objectives that allow students to demonstrate mastery of the AKS. Throughout the year, you may notice that the AKS and IOAs may not be taught in their entirety the first time they appear on the instructional calendar. Some AKS and IOAs will appear multiple times throughout the year. In Unit 3A, AKS and IOA 6D will be repeated. This unit has two AKS. Under each AKS, you will find the Indicators of Achievement, or IOAs. You will also see that we have provided you with the state coding at the end of the IOAs, so that if you are looking up resources on the Georgia DOE website, you are able to find the IOA that is related to the GCPS IOA. For AKS 4, students will identify and compose shapes, analyze their attributes of shapes, and relate their parts to the whole. The IOAs go into further detail about the expectations for the standard. IOA 4A focuses on analyzing, sorting, and classifying 2- and 3-dimensional shapes based on specific attributes, such as number of sides, number of vertices, lengths of sides, number of edges, and number of faces. Students will build and draw shapes that possess defining attributes. 2-dimensional shapes include rectangles, squares, rhombuses, triangles, trapezoids, hexagons, circles, half circles, and quarter circles. 3-dimensional figures include cubes, rectangular prisms, cones, spheres, and cylinders. For IOA 4B, students will use the shapes to compose a new shape. Then they will use that composite shape to form a second composite shape. The final IOA for AKS 4 is 4C. This IOA addresses a student's ability to relate the parts of a shape to the whole. Students will partition circles and rectangles into halves and fourths. They will reason about the size of the pieces. Students will not use fraction notation and are not expected to shade in fractional parts. Students will only describe the fractional parts as halves, fourths, or quarters. We will also continue to revisit AKS 6 through IOA 6D. Students will ask questions and answer them based on gathered information, observations, and appropriate graphical displays. They will use this information to compare and order data. In this portion of the video, we will look at the pacing guide to see how the AKS and IOAs have been paced out over the course of the unit. At the top of the pacing guide, we see the name of the unit, the big ideas for the unit, and the suggested pacing. This unit will focus on geometric and spatial reasoning and measurement and data reasoning. The suggested pacing is about 4 weeks. In the next box, we see the first AKS and IOA or IOAs that will appear in this unit. Unit 3A will begin with AKS 4, more specifically IOA 4A and 4B. Students will also revisit AKS 6 through IOA 6D, which requires students to ask questions and answer them based on gathered information, observations, and graphical displays. The left column of the pacing guide will list the progression through concrete, representational, and abstract strategies. The bullets also indicate the learning objectives for the day, as well as suggested manipulatives. The right column of the pacing guide shows the instructional resources that align to the intended learning objective for each day of instruction. Some days you will see the instructional resources linked for the numeracy components of a traditional teacher-led lesson. Other days you may notice a task-based lesson, which is your full numeracy block that day. So day 1, we see we have a task-based lesson, and day 2 is more of that traditional lesson. This unit starts with IOA 4A. Students will be using attribute blocks, geometric shapes, pattern blocks, half circles, and quarter circles to identify, sort, and classify 2D shapes. The focus for first grade is no longer being able to identify defining versus non-defining attributes. The instructional emphasis will be on using defining attributes to identify, sort, and classify shapes. Students have background knowledge of shapes from kindergarten, so an inquiry lesson has been posted on the first day of the unit. The formative on this day also aligns with the skills that they should have mastered in kindergarten. The next 2 days are traditional lessons at the concrete representational level. Students should have the opportunity to build shapes using geoboards or angle legs, then draw the shapes that they built. 4A will continue, but our focus will shift to 3-dimensional shapes. Students will build 3D shapes with defining attributes. Possible materials can include toothpicks, pretzel sticks, marshmallows, coffee stirrers, and Play-Doh. So we're going to do some building, and then when we get down here, this is about day 7. Students will also see that IOA 6D has been intentionally clustered with IOA 4A. Students will complete a task-based learning lesson that focuses on data collection around students' favorite shapes. So we're seeing that 6D being brought back in and intentionally clustered. After lots of concrete experiences with identifying the attributes of 2D and 3D shapes, you're going to see that we begin to cluster IOA 4B and 4A. We will begin to focus on using 2D shapes to create a composite shape, and then compose new shapes from the composite shape we created. Students will use their knowledge of defining attributes from IOA 4A to describe the attributes of common shapes and the new composite shapes that they formed. You may also notice that some of the student tasks repeat more than once. So like compose 2D shapes is listed on both of those days. Students may engage with a task or different portions of a task on different days. You can adjust the task based on the needs of your students. Again, we see that 6D has been intentionally clustered with IOA 4B. Students will engage in another task-based lesson where they collect data regarding the shapes that they use to create a composite figure. So really clustering those IOAs together intentionally so we're able to work on multiple learning targets at the same day. So we're going to finish up 4B and 4A. And then our final IOA for this unit. The final IOA for Unit 3A is IOA 4C. Students will begin partitioning circles and rectangles into 2 or 4 equal shares. Notice that the bullets say to describe the shares using the words halves, fourths, and quarters. It is also appropriate to use the phrase half of, fourth of, and quarter of. It is not appropriate to use fraction notation or shade in specific pieces of the whole. Students are not required to recognize 1/4 or 1/2, but instead discuss how the number of pieces that a whole is partitioned into affects the size of those pieces. I would also like to point out a specific lesson for you. This lesson, let me open it up. This lesson on the second day of IOA 4C is listed as a traditional lesson. But we want to point out that some lessons you might see will have students do their active engagement before the actual teacher-directed instruction happens. So it is okay to have students explore and then do that teacher-directed, and it still be that traditional mini lesson with your small group components. You will have about 5 days to work on this specific IOA. Students will spend the majority of that time using concrete manipulatives like Play-Doh, paper folding, Geoboards, fraction squares, or fraction circles before progressing to drawing the representational level. Finally, students will be asked to reason abstractly about the size of the pieces and how the number of pieces that a shape has been partitioned into affects the size of the pieces. In this portion of the video, I will highlight specific instructional strategies that will be utilized in this unit. Please refer to the Analyzing the Standards, or ATS, for guidance on additional instructional strategies for each IOA. The first strategy we're going to be looking at today is for IOA 4B. We're going to compose two-dimensional shapes and three-dimensional figures to create a shape formed of two or more common shapes and compose new shapes from the composite shape. This is what a lesson might look and sound like for this IOA. Deandra says she can combine two triangles to create a four-sided shape. Do you agree or disagree with Deandra? I need to figure out if I agree or disagree with Deandra. She says she can combine two triangles, or she can put together two triangles to make a four-sided shape. She thinks that putting two three-sided triangles will make a four-sided shape, and I have to figure out if I agree with her or if I can use the pattern blocks to do that. So let me start first with what I know about my triangles. I know that a triangle has three sides, 1, 2, 3, and 3 vertices. 1, 2, 3. This triangle also has 3 sides, 1, 2, 3, and 3 vertices, 1, 2, 3. And I want to know if I can put them together to make a four-sided shape. So let me see. If I stick their sides together, look at that. I made a new shape. My new shape has 1, 2, 3, 4 sides, and 1, 2, 3, 4 vertices. It even looks like a shape that I recognize. It looks like my blue pattern block, which is my rhombus. It has 1, 2, 3, 4 sides and 1, 2, 3, 4 vertices. Oh, so it sounds like I do agree with Deandra that I can combine two triangles and create a new four-sided shape. When I combined two triangles, I made a rhombus, which is a four-sided shape. Well, now that I've started doing some of this thinking, I wonder what other shapes I can make. Let me see. I made a rhombus with my two triangles, I wonder if I can use that rhombus to make a new shape from that. I'm going to use another triangle and let's see what I'm thinking. Oh, I know. If I add another triangle, then look, I made another four-sided shape. I'm going to add a triangle down here as well. Oh, this shape has 1, 2, 3, 4 sides and 1, 2, 3, 4 vertices. This, I combined my rhombus with my triangle because that rhombus was the same as those two triangles. And 1, 2, 3, 4 sides and 1, 2, 3, 4 vertices. I made another shape that I know. I recognize that it looks like my red pattern block, which is my trapezoid. Oh my goodness, you guys. So it's really cool that we can use shapes to compose a new shape. And then I can take that new shape, add to it, and compose another shape. So now what you would want to do, teachers, is give students the opportunity to explore a little bit. You might want them to take the original two triangles and see what they can make from there. You might have them have the opportunity to take that trapezoid and see what they can make from that. But you want them to see that this is kind of like a two-step. They're going to take shapes, compose a new shape, and then take the new shape that they made to make another shape. So you could have them think about how could they use what they made to make this hexagon, but giving them lots of opportunities to explore and really do this thinking with their pattern blocks and exploring with pattern blocks. Anyway, 4C, which is partition circles and rectangles into 2 and 4 equal shares, and justify reasoning about the relationship of the parts to the whole, students will have the opportunity to use Geoboards. It is really important that we model how to use these boards, how to struggle a little bit while we're using these boards, and point out some things for students to notice. So one thing for them to notice is that not all squares and rectangles will be able to be partitioned into halves or fourths because of the pegs. So if they're thinking about how they may have partitioned horizontally or vertically, there may not be a peg there for them to do that thinking with. So if they find that they're having trouble being able to do that, then you can encourage them to create a different rectangle and try partitioning that. So for example, this rectangle, I can partition into halves using that vertical peg that's in the middle. So it shows my two equal pieces. Something else to consider is some of the rubber bands are a little large, so they might have some trouble actually getting the rubber band to stick. You could see I kind of had to double wrap that one. You could have them extend the rubber band further and they can still see where the partition would be. Or you could have them double or try to find a rubber band that's a little bit smaller. The other thing that we can encourage students to notice with the Geoboards is that we can partition the squares and rectangles in different ways. So I might take this square and partition it into halves that way. I can also show it being partitioned into halves this way. Or working with the squares on the Geoboard gives them the opportunity to see those diagonal partitions. So really start thinking about how we can partition shapes in different ways, but the size of the pieces will remain the same. That gets us to really thinking about how the size of the pieces relate to the whole and how more partitions lead to smaller size pieces. So we can have students create two of the same squares, and we can show that this one has been partitioned into halves. So I'm going to mimic that with this other square. And I know that both of these have been partitioned into halves. This is 1/2, and 2/2 is the same as a whole, right? 2 of 2 pieces is a whole. If I take that same rectangle or square that has been partitioned into halves and partition it again into fourths, then I can see my square stayed the same size. But when I partitioned it into 4 pieces, the size of those pieces got smaller. So we're able to get students to start thinking about how the number of partitions will change the size of the pieces. The more pieces that we cut a hole into, the smaller the size of the pieces is going to be. After students have had ample opportunities to partition shapes on the actual geoboard, you can have them move to a concrete representational level. So first you would have them build, and then you can show them how to copy what they built onto the paper. So you're going to want to print geoboard paper that matches the geoboard. So it's going to be 5x5. Which we have also linked on the pacing guides. So I can see that this particular shape went over 1, 2, 3, and then goes up 1, 2, 3. So starting in my corner, I am going to connect the dots up 1, 2, 3, over 1, 2, 3, down 1, 2, 3, and back over 1, 2, 3. Now, this shape was partitioned into halves diagonally. So they can connect the dots diagonally so that what they draw represents what they built. And this would be 1/2. And this would also be 1/2. Notice that we're writing the word 1/2. We're not using fraction notation. We're not shading anything in. We're really only thinking about this is 1/2 of the whole. This is 1/2 of the whole. And if I have both of those, then I have the whole. So if I have 2 halves, then I have the whole shape. So the same thing would happen if we were doing our fourths. Same thing, draw the 3x3, show that diagonal partition, show the other diagonal partition. Now with fourths, we can label these piece fourths. This is 1/4 right here, 1/4. Or I can also refer to it as a quarter. This is a quarter of the whole or 1/4 of the whole. Again, we're not doing any shading. We're really just thinking about the size of the pieces. This allows them to really think, well, when I'm looking at 1/4 and 1/2, the fourth is a smaller size piece than the half. And that's really why we're really kind of doing that 1/2, 1/4 thinking. It's not for them to use fraction notation. It's really just to be able to talk about the size of the pieces and those pieces in relation to the whole. So we have our 2 halves is 1 whole. And if we have all 4 of our 1/4 pieces, then we have 1 whole. And when I take that whole and partition it into 2 pieces, I take the same whole and partition it into 4 pieces. The size of the pieces gets smaller because we are partitioning the whole into a greater number of pieces. So we can transfer the learning that we're doing on those geoboards to a representational level to allow students to show you what they did with the geoboards as well. So a little bit more accountability if you're not able to watch them as they're building. the teaching them to record their thinking using a representational model will kind of help you assess what they actually did with the Geoboards. Today, we've talked about different strategies. We've also talked about using concrete, representational, and abstract strategies in the previous video. So, which strategy should we emphasize? In mathematics, the emphasis is on reasoning and thinking about quantities within mathematical context. Specific mathematics strategies for teaching and learning are not mandated by the Georgia Department of Education or assessed on state or federally mandated tests. Students may solve problems in different ways and have the flexibility to choose a mathematical strategy that allows them to make sense of and strategically solve problems using efficient methods that are most comfortable and make sense to them. It is critical that teachers and parents remain partners to help each child grow to become a mathematically literate citizen. These standards persevere and affirm local control and flexibility. Thank you for watching our video today.